2D, 2E, 6, 7, 8C, and 10. Okay, so let's just look at the last few questions then. Question 7. Alright, so in question 7, okay, in part I, you're given that y is equals to e cosine x. So dy over dx, to differentiate e cosine x, or rather e to the power of cosine x, we will have the same e to the power of cosine x first. Then we differentiate our cosine, okay, which is going to give us negative sine x. So, to rewrite that, we can write it as negative sine x e cosine x. Okay. Then in part 2, I think that is where the issue may come from. We want to actually integrate sine x e cosine x plus 1 dx. Okay, so as per usual advice, whenever you are dealing with hence question, where earlier on you have done your differentiation, first step that we shall do is to work on integrating whatever answer that you have gotten. Okay, and then dx, and get it back to your original, which is e to the power cosine x plus c. So we always work with this first, okay? But then because the question here is instead of e to the power cosine x, we have a plus 1. So what we can do and we should observe is that we can do some form of expansion first. Where we have to be integrating sine x e to the power cosine x plus sine x. Right? Okay. But then because in our earlier question, we have this negative sign over here, while in this section of the answer, of the question, right, there is no negative sign. So we can manipulate some things out of this. This actually says that integration of sine x e cosine x dx, I can take out the negative 1, okay, which actually can be brought to the other side of the equation to see as negative e cosine x minus c. Agree? Okay, so I took out the negative sign, okay, and brought it over here instead. Alright, so we know how to integrate sine x e cosine x. We bring it here, okay, that is actually negative e cosine x minus c. Okay, then the next issue comes with our sine x. Integration of sine x, we are definitely aware of that, okay, that will actually give us plus negative cosine x. Okay, and then we get a plus d. So, this part here is this section. Okay, so we simplify, tidy things up. We have negative e cosine x minus cosine x. We can combine all the constants to become a plus f. Okay, so that will be the answer. Okay. Now for question 8c, want to be integrating this, what are we supposed to do first? Are you able to start off doing this question? Let's see. So so what should we do first? Partial fractions, right? Okay, so take out that fraction without the integration. Our partial fraction should be of this form. Okay. Then multiply throughout by this larger denominator. Get this? Okay, then you will be left to a matter of solving for A, B, and C. Okay, or just do 1, alright? So A is equals to 1 and 2, 1 over 25, okay? I'll leave the working to you. C is negative 9 over 5. B is equals to 12 over 25. Okay. Could I erase the earlier one, question 7 already? Okay, then, so that means that our integral will be we'll be looking at equals to integrating 1 over 25, 2x plus 1, plus 12 over 25, x plus 3, minus 9 over 5, x plus 3 squared dx. If you're unable to see it, okay, this is 1 over 25 with your 1 over 2x plus 1 plus 12 over 25, 1 over x plus 3, minus away 9 over 5. This is x plus 3 to the power negative 2. Okay, so the first two fractions will become your ln, but this one we just use our usual power rule. Okay, so we would get our 1 over 25 ln 2x plus 1 over 2 plus 12 over 25 ln x plus 3. Strictly speaking, it's like over 1 because your coefficient of x is 1. Minus away 9 over 5. Let me just bring it down. Minus away 9 over 5. X plus 3 to the power negative 1 over the power negative 1 and the coefficient of x. Simplifying that, we will have 1 over 50 ln 2x plus 1 plus 12 over 25 ln x plus 3 minus 9 over 5x plus 3 plus c. Oops, sorry, forgot plus c here. Okay? Any questions for question 8C? Yes. Oh, plus. Yes, thank you. Forgot minus. Okay, I put plus else here? Yes. Anything else? Okay. Last one, question 10. I am guessing that for question 10 is regarding solving part I. Is it? Part I already got issue, right? Okay. Erase this part up. Coordinate of the stationary point. So stationary point will mean that your f prime x must be equals to 0. So when f prime x is equals to 0, this is equals to 0. Then I guess you don't know how to do it, right? Okay. This is your solving by substitution in your exponential functions, yeah? Okay, if you recall, e power negative x is e to the power x in the denominator. While this, okay, I can re-express it using my indices to write it as e to the power x to the power 3 times e to the power x equals to 0. See that? Okay. I'm sure you recall the method by substitution, that u equals e to the power x. Remember that? 2 over u minus 3u cubed times wait, this is not x, sorry, just e to the power 1. 3 eu then cubed equals to 0. E is a number. Okay? Then I multiply across by u. So I have 2 minus 3e u to the power of 4. Manipulate things a bit. So 3e u to the power of 4 is equals to 2. That means u to the power of 4 is 2 over 3e. Okay? And that tells us that u is equals to the 4th root, or in other words, 2 over 3e to the power 1/4. Okay? So because u is actually e to the power x, we are saying it as e to the power x equals to 2 over 3e to the power 1/4. So change into logarithmic form. So ln 2 over 3e to the power 1/4 is equals to x. So x is equals to 1/4 ln 2 over 3e. Did the question require it exact? Oh yes, it says exact. So, depending on the form that they require, okay, this technically you can simplify it. Okay, we have 1/4 ln 2 minus ln 3e, right? Okay, ln 3e is your ln 3 plus ln e. Ln e is 1. So ln 2 minus ln 3 is ln 2 over 3 minus 1. So that's how we get this answer. I guess this is the answer in your textbook. Am I right? Okay. Then part 2. It asks you to find out what is the actual equation for y. So we need to do our integration. So we integrate f prime x. That will give us 2e to the power negative x over negative 1 minus 3e to the power 3x plus 1 over 3 plus c. Simplify it. We have this. Okay. Question actually gave an additional information saying that at the y-intercept itself, your y value is equals to 3. So y-intercept is where x is equals to 0, y coordinate is 3. So that means that 3 is equals to negative 2e to the power of negative 0 minus 3, 0 plus 1 plus c. So substitute it in. We find that c is equals to a, wait. Okay, I do it correctly. Negative 2. Oh, sorry, what am I doing here? Why is there a 3 here? E to the power of 0. So C is equals to 3 plus 2 plus E. So that's 5 plus E. Therefore, Y is equals to negative 2 E to the power negative 6x minus E to the power 3x plus 1 plus 5 plus E. Okay. Any questions? Okay, if not, you may submit your homework to the front. In the meantime, I would also like to return to you your 15.1 and 15.2. Amanda, the homework from this group. Emily. Sorry? Submitted already. Oh, Joanne not submitted, right? Yeah.
Good evening.
sorry, it's not completed. Some things that I want to point out. Yeah. And I will go through. Yeah, I better go here. Go through question 14. Okay. I just want to look at exercise 15.2, question 14, right? I'm really concerned about the concept that you all have. Okay. The question is found on page 82 of your textbook. Okay, this is exercise 15.2. Question 14. So, in your textbook, right, okay, the question says that given that y is equals to e to the power 2x over x, for x more than 0, we want to find the range of values of x such that y is a decreasing function. Okay? When it comes to differentiating and knowing that decreasing function means your first derivative is less than 0, that one is not an issue, okay, for most of you. So you can give me this very well. Okay, just that for some of you, you don't factorize it. Okay, when it comes to doing decreasing function or just a general rule of thumb, we try to factorize as much as possible. Okay, so most of you can do this. Then you can also tell me that dy over dx is less than 0 for decreasing functions. So with this idea, most of you can also illustrate this to me. Okay, but the problem is the next few steps. Okay, most of you give me e to the power 2x, 2x minus 1 less than 0. Then you tell me e to the power 2x less than 0, 2x minus 1 less than 0. Then you tell me this one reject because e cannot be less than 0. And then you say x is less than half. Okay, this is a completely wrong concept. Okay, wrong. Why is it wrong? Let me erase this first. Okay, reason is because if we fall back into our quadratic solving, right? If you remember what we do if let's say have this, okay? What we do when we have quadratic inequalities, we never actually say this, alright? We don't ever say this, right? How we should go about doing our quadratic solving is that we draw graph. Okay, negative 1, 2, less than 0, so therefore we get this answer. Right or not? That's the concept. So because it doesn't work over here, surely it will not work over here either. Okay, so you cannot say this is actually going to break it up like that. Because this is an inequality, it is not an equality. Okay, so we need to look at factor by factor about the function itself. Okay, so the correct answer from here, we look at 3 different factors contributing to this entire expression. One being here, another being here, and another one being here. Okay, so we see that this is e to the power of 2x. question told us that x is always more than 0. Okay? Even if x is less than 0, for whatever value of x, exponential will always be more than 0. So since x is more than 0, e to the power of 2x is surely more than 0. Okay? What's more, is x squared, we can also know that surely it will be more than 0. It will never be equals to 0, because in order for this to be equals to 0, x must be 0. Okay? So, we tackled 2 out of the 3 things found in the expression already. Okay? Then, the next thing is regarding this 2x minus 1. Okay? So, in order for the entire thing to be less than 0, right? Because the question said it's a decreasing function already. If this part is positive, this part is positive, this section must be negative. So that positive number times negative number, I get negative. Negative divided by positive number, I will still get negative. You understand what I'm saying? Okay. So you go back to your very set 1 concept of negative, negative, positive, positive, negative, negative, just fine. Okay, so therefore, since dy over dx less than 0, your 2x minus 1 must be less than 0. So that is the thought process that you should be having. It is not about rejecting it at all. Okay? So 2x minus 1 if it's less than 0, question actually wants us to find the range of values of x. So we go into solving our usual inequality. So we find that x is less than half. But since the question started off saying that x must be more than 0, so therefore, x must be more than 0, but it must be less than half. Hence, this is the inequality to have as an answer. Okay? So I hope that it clarifies about your concept, okay, when it comes to determining values or solving inequalities in general. Okay? Any questions? Okay. Not, then let's go into our 2019 paper. Don't have a lot of time, but let's just go through whatever that we can today. How do you find the paper? Easy, difficult, average? I don't think anybody will say easy lah, huh? Okay. Not that I look down on y'all, but I think that this is mid-year exam, right? Y'all don't have much time to study with your CCA commitments and all that. Okay. I don't have the version that y'all hold. Okay, so please let me know if I have accidentally skipped any question or the question I want to go through doesn't appear. Okay. I think your first question is this one, the binomial one. Am I right? Yes, no? Okay. Can do the binomial one? Yes, no? Can you give me some response so that I can do, huh? But is there a no? No? Okay. Oh, this is our first question. Okay. Alright. Let's get started. Okay, so it says by considering the general term. What is the general term? General term can be found in formula list. I don't think the formula list was printed for you. I printed for you before a long time ago. Okay, so from general term is found here. Okay, whereby this term itself is the t term r plus 1. Why? Because this is the first term, this is the second term, and notice the pattern. Second term, this one is 1, so this one third term, you get 2, right? So now it's r, so therefore it must be r plus 1 term. Okay, so this is your r plus 1 term, which is also what we call the general term. So what we have to do is recognize that this is the A to be used and this is the B with the negative sign, yeah? Because down here is minus, our formula gives us plus. Okay? So that means that, let's use a blue pen. Our TR plus 1 is equals to N is actually your 8. Choose R. Then A is your 2x cubed. Okay, to the power of N, which is 8 minus R. Then your B is negative 1 over 4x to the power of 5 to the power of R. Okay, because formula is N choose R, A to the power of N minus R, B to the power of R. Okay, then what we do next is that we try to simplify it because the question wants us to find the term independent of x. Term independent of x, that means x is to the power of 0. Okay, but our x is all over the place, so we must simplify into a coefficient portion and a x portion, variable portion. Okay, so in this case, we see it as 2 to the power 8 minus r, x cubed to the power 8 minus r, so we split it up. Then this one, don't forget the negative sign. Usually take the negative sign separately. It is the negative 1 to the power of r. Okay, just put it out separately. Then we have 1 over 4 to the power of r. X to the power of 5 is in the denominator. That gives us x to the power negative 5 to the power of r. Okay, so now put things together where they belong. 2 to the power 8 minus r, negative 1 to the power of r, 1 quarter to the power of r. So all the numbers together, x you put it together, this one can simplify, x to the power 24 minus 3r, this is x to the power negative 5r. Okay, could be further simplified. Usually the negative 1 just put it in front more. Okay, then this is base of 2. This is 1 quarter. 1 quarter can be expressed as a base of 2. That is 2 to the power negative 2r. Okay, this can be combined. X to the power 24 minus 3r minus 5r. I really recommend that you do things step by step. Don't try to skip steps. So this is negative 2r. Minus 3r minus 5r, you get negative 8r. Okay, this negative 1r, you notice that it's always standing alone by itself. Just let it be. Okay, we cannot evaluate whether negative 1 to the power of r, is it going to be positive or negative in the end, because it highly depends on the r value itself, whether it's even or odd, which we do not know. Okay, so 2 to the power 8 minus 3r, x 24 minus 8r. Okay, so now we arrive at the coefficient portion, meaning to say all the really independent numbers and then the variable portion. Okay, so we just now understand that independent means x to the power 0. So our 24 minus 8r must equal to 0. That is how we go about determining the value of r. So r is equal to 3. So that means x to the power 0 is just 1. Your independent term is just the coefficient actually. So term independent of x will be equals to 8 choose 3, negative 1 to the power 3, 2, 8 minus 3, 3, and we get negative 28. Okay, I hope you remember how to key in 8 to string, use calculator. We press 8 and then your big letter C. Where's my calculator? Oh, it's here. Okay, and choose R. So and choose 3, it's C3. You get 56. Okay, press the entire thing in calculator. No need to do it parts. Alright? Okay. Binomial is must know how to do. Okay. Should also don't lose marks in binomial as much as you can. Okay. But of course binomial has its challenges, which is in algebra. So the simplification part, need to practice it. Okay, let's move on, shall we? Next one, question 3. This one. Okay, this is your linear law. I think it is chapter 6 in your volume A textbook, or chapter 8, I don't recall. Okay, so this one is the one where you don't need to draw graph one. Okay, so notice that it says x plus y is plotted against x squared. When it's traced like that, this is always the y-axis, this is always the x-axis, or in other words, big Y, big X. Okay. So straight line passing through the points 1, 2, 4, -7. So to imagine how this looks like, okay, I don't know whether the graph is upward or downward sloping. Okay, it doesn't quite matter. You can just try to imagine it. 1, 2 maybe about here. 4, -7 actually is below. So if you want to, it may be helpful to draw something that is realistic. Okay, so our graph may look something like this. Straight line graph. Okay, because question also says straight line. So this part here, the x-axis, is actually your x squared. This is your x plus y. We want to find the values of small x when small y is equals to 1. Right? So your usual linear law applications, we always go and find gradient. We always go and find the intercept value. But in this case, it might not be easy to find intercept since you're not drawing the graph at all. Okay, but let's go ahead and find gradient first. Okay, so using your gradient formula, difference in the y coordinates over difference in x coordinates, we will get -3. Okay, what this means is that your equation of the line, equation of straight line is always y equals mx plus c. But more particularly, big Y equals to big big Y equals to m big X plus c. So this is your big X, this is your big Y again. That means that our x plus y equals to gradient -3. Big X is x squared plus c. Okay, if you're not comfortable with this, you can always put y equals to -3 big X plus c. This might be easier because we need to find the y-intercept now, the value of c, which we can't tell from the graph because this is not a joint to scale graph. So then we have to do algebraically, okay, to solve for the value of c. How we do that is to actually use the points over here. Okay, you can use 1, 2, or you can use 4, -7. So let's say if I use 1, 2, don't forget that the points is for big X and big Y. So this is for big X and this is for big Y. Okay, so that means that 2 is equals to -3 times 1 plus c. Don't substitute wrongly. And we find that c is 2 plus 3, that is 5. Okay, so that means that our big Y equals to -3 big X plus 5. Okay, going back to the objective of the question, we want to find small x. Okay, so we can convert it back into x plus y equals to -3 x squared plus 5. So now when small y equals to 1, so x plus 1 equals to negative 3 x squared plus 5. Okay, so x plus 3x squared equals to 5 minus 1, that's 4. So x squared is equals to 1. Okay. Hang on, did I do the wrong calculation? Oh, sorry. Why am I getting this? 3x squared plus x. Okay. Sorry. So 3x squared plus x. 5 minus 1 is 4, so minus 4 over here. We factorize, yeah? Okay, so it's about solving quadratic now. So x is equals to 1 or x equals to negative 4 over 3. When solving quadratic, a reminder, please make sure you show me the working by factorization or by the formula. Okay, then we have this as the answer. Okay. Next, question 4. Is there an issue with question 4? We just covered this topic. Do you need me to go through this question? No need? No need, then I don't go through, Okay. I hope you check your answer already. Answer should be y equals 1 over x minus 3 over 2. X squared minus 2x plus 5 over 2. Okay? If you need to see me about it, please do come and see me. Okay, question 5, the sketch, no need to sketch. Okay, not part of your syllabus to sketch. Were you given this question? Not inside, right? Okay, great. It was? I is lah. Okay. Part 2, solve simultaneous. Need me to go through? Okay. I'll just save some time by not writing. I'll just go through. Find the coordinates of the points of intersection of the curve. Y equals to 2 square root x. Submit inside 4y equals 3x plus 5. Submit already, you get this. Okay, in A maths, usually solving simultaneous is always done by substitution. Okay, we very rarely do by elimination. So then we will get this. Okay, the key concept is to let u equals to x to the power of half. Then it will be easier. Okay, so that you can get a quadratic. Okay, so this will be the key method over here. Then factorize. U is equals to 1 or 5 over 3. That means square root x is 1 or 5 over 3. So x is equals to 1 or 25 over 9. Y is 2 or 10 over 3. And don't forget, question 1's coordinates, so make sure you answer with coordinates. Question 6 on your certs. No need. Question 6, certs. Our area should be 7 square root 3 minus 12. Okay. Then the height should be 6 square root 3 minus 9 over 3. Okay. Then, question 7, your differentiation actually. Question 7, need me to go through? No need. Then I'll skip, yeah? So, hope you can show it. Maximum. Make sure you always check second derivative test, or you can do first derivative, that's fine as well. Okay, so that's always something that happens to be missed out on in terms of proving that it's maximum. Okay. Question 8. Were you all given the question? No. So this was not given in the question? No. Oh, okay. Why don't I just go through this one? Okay, because it's still, part I is part of the syllabus. Okay, where's the answer? Okay. Maybe you want to take a photo of the question for your convenience. Okay. So the question says that it shows part of the curve where x is not equals to 4. Explain with working why the curve has no turning points. So no turning points, what does that mean? When will there be turning points? Having turning points means what? dy over dx equals to 0, right? So no turning points means dy over dx is not equals to 0. So we will definitely have to do our differentiation first. Okay, so we have 24 x plus 4 to the power negative 1. Differentiating it, we bring down the power minus 1. And differentiate x plus 4, we get 1. So that is negative 24 over x plus 4 squared. Looking at the derivative itself, okay, we see that for all real values of x, we know very well that x plus 4 squared is more than 0. Right? So because this is going to be positive, down here is negative. So overall, okay, the fraction for dy over dx, the expression for dy over dx will surely be less than 0. Okay, so therefore, dy over dx will be less than 0. So since it is less than 0, which is not equal, which has the same meaning as not equals to 0, the curve has no turning points. Okay. Question 9. Factorize completely. Cubic factorization. Are you able to do it? Can do. This one your Sec 3 work. Cubic factorization. Can, right? Okay. So do your factor theorem. Do long division. Okay. Then fx is equals to x minus 1 times x squared plus x minus 2, which is the quotient here. Factorize fully. Okay. Then partial fractions can do. Right? Your constants might not be the same as mine, but you should be getting A is 34 over 9, B is negative 25 over 9, C is 13 over 3. Very often when it comes to partial fractions, your A, B and C constants are usually in fractions. Okay, so it is normal, but it's always good to check. Okay, how to check? You make sure that when you substitute x equals to something over here, the values that you get must be the same as when you substitute x equals to something over here. Usually I like to substitute in x equals to 2. But of course we must see the denominator. If the denominator ends up becoming a 0, then avoid that number. Okay? Next, question 10. Question 10 is not given to you. Right? Question 11. Circles. You need to go through? Okay. Shall go through then. So it shows two concentric circles, C1 and C2. The equation of C1 is this equation. We want to find the center and the radius of circle C1. Okay. So using the equation itself, you will be able to manipulate it. So what I have taught you is to remember this form, expand it, okay, then simplify, group them together. We will compare with this original equation. So negative 2a equals to 4, a is negative 2. Negative 2b is negative 6, b is equals to 3. So negative 2 square plus 3 square minus r square equals to 4. R square will be equals to 9, r is 3. So therefore, center is negative 2, 3. Radius equals to 3 units. Okay. I also want to bring to your attention to highlight to you in terms of presentation and making good use of the blank space inside your paper. Okay, Joseph, you're one of them. Please make sure you try to write on the side first, left to right. Please don't write your answer right in the center. Then you arrow point here, point there, point everywhere. I think one of the tests that I gave you for email is point here, point there, point everywhere. I don't know whose one is it, I forgot already. Okay, Joseph, yours right. Okay, please you don't arrow here or there. If I miss out one arrow, then what am I supposed to do? Okay, it's your loss, not my loss. Okay.
Why is the booklet not enough space?
Huh?
Why is the gift not
Okay, good question. Why is booklet not enough space? Raise your hand, ask for extra paper. Okay. However, do be aware that in O-level itself, okay, if you ask for extra paper, they will give you an extra writing booklet. Okay, it is a booklet that has writing lines, inside it. Okay, the instruction based on what I see from the previous invigilation is always, these extra booklets are always being kept in between your original question booklet. Sorry, I have no other better word for the word kept. Okay, if you know a better, more professional English word, please educate me about it. But they will ask you to keep it inside. If it falls out, okay, then that's it. Yeah, but of course, we always prevent it from falling out. Then you must also write your index number on the question booklet itself. Okay, so there is always that risk. So I just want to let you know about it. Okay. Part B. Okay. You want me to go through this, or because the time is running out, or you want to go from lunch and go through tomorrow? What does that mean, Rita? You want to go through anymore? Is it? Then shall I go through tomorrow? Yes, okay, so that your brain is more fresh. Alright? Okay, so tomorrow I'll finish up this paper 1, then paper 2 I'll continue